What is the answer to the ultimate question of life, the universe, and everything? The famous one given by Deep Thought, Douglas Adams' alien supercomputer, after 7.5 million years of calculation, was frustratingly simple. 42. 1. What was this ultimate question then? 6 times 7. Therein lies the problem. When we ask questions of computers, we want them to understand us. We want them to understand what we meant. Therefore, sometimes we need a little help knowing exactly what to ask. In essence, this is my project with MySociety. Could we add a feature onto their site, Cape, which allowed you to search not by what you typed, but by what you should have typed? Who are MySociety? They're not-for-profit, working on aiding transparency, democracy, and community in society. They use technological solutions on various websites. They recently added Cape to their arsenal, in partnership with CUK, collating hundreds of climate action plans from across the UK. They've then scored them on how well they're implementing policies. My focus was on the search function on the site, which allows you to Control F or directly search through the database. This should allow a concerned citizen to find out about new recycling centres in his council, or an anxious motorist about new charging networks before he commits to a new electric car. However, it should also allow a more broad search through the entire database, so council officers, when drafting new plans, can get inspiration from what's already been done. Or campaigners can put pressure on their local council by being able to cite evidence of what's successful. The problem is, at the moment, this search just isn't powerful enough. Control F, when we search for something general, brings way too many results of every instance of the words. And for something specific, we lose out on lots of key, useful topics which are just worded differently. What we need is some AI which can suggest things of what we should search by having the equivalent knowledge of an expert. This is where BERT comes in. His full name is Bidirectional Encoder Representation from Transformers. It's a mouthful, so we call him BERT. And he acts as our supercomputer, although unable to answer life's biggest questions, can help improve our search. He's trained on the nuances of English language, so once exposed to our database, he can improve our site with two key functionalities. The first is a semantic or meaningful search. This allows us to suggest alternative results that we know are in the corpus based on the context and the meaning of what you put in the search bar. The second is to tag our individual plans so that we get an idea about what a plan is about without having to read through the entire text. How do we do this? First, we work BERT hard, exposing him to lots of different variations of the corpus. Cleans with and without punctuation, with and without word endings, only nouns, etc. He embeds and then extracts a key phrase vocabulary. We then work him hard again, this time with a focus on the diversity of results, so we get the widest, most interesting representation of our database. This leaves us with about 13,000 key phrases. So what do we do with them? Well, before, a council officer who is interested in conservation efforts would have to Control F for conservation, and then with a few results, bang his head thinking about what are some other terms we could search for which are useful. Whereas now with semantic search, we're directly linked into loads of interesting topics which are really useful and mean we can come away from the site knowing a lot more about the topic we're interested in. The same for that motorist, who before would Control F to begin with, can now start exploring the site a bit more. With our threshold similarity score between key phrases, we can lower the threshold, allowing more and more useful terms. Here, we've now tripled the amount of useful information we can get. What about those tags? Well, we can take every keyword from our vocabulary and link them by the threshold similarity score, weighted between edges, and then we can color by the total number of connections. The result is unusable. However, if we begin to trim that graph, only keeping the important nodes, well, this is starting to look a little bit more usable. If we do this again and again, we're left with just a few hundred key phrases that we know are relevant in our corpus. And by cherry picking a few hundred maybe, we can now look at the most relevant things to tag our plans with. All that's left is to put this online. Here we see one of these plans with these useful tags, meaning we know a lot about what this plan is about without having to read through the entire text. We'll get an example of our semantic search. We've stayed conservative here with quite a high threshold similarity score, But we're still getting useful topics come out like species extinction, species diversity, and sustainable ecology. These are a couple simple improvements to the site, which vastly improve the user experience. A user can spend much less time on the site, but come away with much more knowledge. Thank you.